With recent advancements in machine and deep learning, much attention has been turned to automated trading programs called robo-advisors that are powered by AI technologies. In this presentation, we present two types of intelligent agents using genetic algorithms and reinforcement learning respectively that are capable of tactical asset allocation in portfolio management. Our agents have reaped substantial returns of up to 200% in our backtest on a 9-year investment horizon, comparable to real-life portfolios managed by various asset firms.
Global stock market losses have topped 16 trillion US dollars in just 52 days since fears over the coronavirus gripped the world.
Our work picks up from this FYP project done by Eddie Lim, who had investigated and developed GA and RL agents for the stock market. Our objective is to extend Eddie's work by incorporating more practical elements of the stock market, such as currency exchange rate and currency risk, as well as apply train test split experiments. In our work, firstly, we look at further testing of the GA agent on international markets of different sizes, mainly large, mid, and small cap markets. In-depth analysis of the experiment data showed a large number of trend reversals detected by the MACD indicator, typically about 7 to 800 in the 10-year period. With an average commission fee of around $200 per trade, this amounts to a huge total of 200k to 150k loss. We surmise that the GA parameters learned by the GA agent during the training period is suboptimal for the test period. Our solution is to first reduce the large number of trend reversals by combining MACD with another trend indicator. We had chosen oscillator K as our secondary trend indicator. With the incorporation of exchange rates, we added a fourth market component, currency risk. Next, our proposed adaptive GA algorithm goes as follows. First, we initialize the GA agent with a set of GA parameters trained on the stock prices in the train set of year 2010. Then, we tested the GA agent from 2011 onwards. We set a moving stop loss using the Bollinger lower band. When the GA agent portfolio value falls below this moving stop loss, we will stop the testing process. Next, we will train a new set of GA parameters using the past 3 months of data. Finally, we continue testing the GA agent again until the end of the investment period. After much investigations and experiments, we came up with a much improved risk equation dubbed the sigmoid risk equation. Firstly, we changed the risk metric from CVAR to annualized downside volatility. Next, we tried various metrics for swing potential but did not find any metric with significant improvement over the existing metric. Thus, we supplemented the existing metric with an additional GA parameter, C3. Finally, we changed the equation to using the sigmoid function. We find that the adaptive GA agent now typically achieve the best or second best portfolio. Overall, our adaptive GA agent have achieved up to 183% total returns upon the initial investment amount of $300,000. For reinforcement learning, Eddie had previously tested RL agents trained on Q-learning with an epsilon greedy policy. We first attempted to apply a train test split, but we observed poor returns. We discovered similar reasons to the initial GA experiments for the poor returns. In-depth investigation of further experiments revealed the following observations. Number 1. Multiple actions can have similar step reward values. Number 2. Without an update policy, if the market trend remains constant, like in the index market shown below, your LL agent performs well in the test period. We surmise that if at each trend reversal, the action taken may be optimal, however, an action taken may not be optimal for the holding period. Thus, with the two findings in mind, we proposed a novel update policy with two key features. Number 1, we only update the RL agent when necessary. Thus, we incorporated a Bollinger Band moving stop loss and only update the agent during the test period if the portfolio value falls below the moving stop loss. Number 2, for the update policy, we propose rewarding all possible actions at each state. Thus, actions with similar reward values will all be rewarded. we tested our novel approach on our 4 markets using the full swing action set for the same test period as the adaptive GA agents. Worthy of note is a large market where the IR agent is able to fully capture the sudden bullish spike of the Shenzhen Medium Risk Index in 2015. This is a feat that the adaptive GA agent could not achieve. We also tested a novel update policy on the gradual swing action set. In all markets, the best agent was able to outperform the best index, except for the index market and in the small market. We compared our agents to existing technical portfolios from various asset firms. Overall, we find that our agents are capable of making returns of similar scale to real-life portfolios from various asset firms, or outperform the best index in their respective markets. This shows that our objective of creating intelligent agents capable of making optimal tactical trades in unseen market conditions have been achieved. For future work, we suggest exploring more options such as testing on a larger basket of equities to test the robustness of the intelligent agents.